and good day, Algebra. We are here covering PO55, graphing a parabola. In PO53, we kind of talked about the characteristics, direction that it opens, the vertex points. Today we're going to kind of tie it together and how we can put these on the coordinate plane so that eventually we can look at a graph, we can analyze it, we know what it's trying to tell us, and we can use them in real context. So as that wonderful video that we just watched said, there are essentially 3 points that they're trying to find, okay, in order to graph a parabola. With lines, we only needed 2 of them. We had the y-intercept and we had the slope we can connect with the line. But because the parabola is either a U-shaped, like a smiley face, or a frowny face, we need 3 of them. That vertex point, and then 1 on either side of it. So it's important to note that parabolas are in this standard form, the same standard form we've been working with in PO49 and PO50 with factoring. Y equals ax squared plus bx plus c. Okay? The vertex points. It's actually a little formula that we get to use here. The x value of the vertex, because it is an ordered pair, so it's an x and a y, the x value is found by taking negative b over 2a. Okay? Negative b over 2a. And where do b and a come from? Well, they come from the values that we have in our given equation. All right? Once we get that, to find y, we plug that x value into the original equation and solve for y. Negative b over 2a gives us x. That gets plugged into the equation to solve for the y variable of the vertex. Any guesses as to what our y-intercept is going to be here from this equation? How we be able to look at this equation and know what the y-intercept is? Carolyn? C. Not b in this case. It was b in slope-intercept form. Oh, you said c. Sorry. Yeah. C is correct. Do you know why?
I don't know. I just know.
It's that constant, right? Yeah. The reason why is because that y-intercept, that x value of 0, think about what happens when we plug in 0 in for x into this equation. What happens to the ax squared term? Becomes 0. What happens to the bx term? Becomes 0, right? So what we're left with then is just y equals c. And so again, it's that constant value that is the y-intercept. And finally, the reflection point, the third point that we need for a parabola, it is the y-intercept reflected over the axis of symmetry. The y-intercept reflected over the axis of symmetry, and we'll take a look at what that looks like when we start to graph them down below a little bit. Mathematically, how the reflection point kind of ties into the vertex and the y-intercept. As an ordered pair, the reflection point will be negative b over a c. Okay, negative b over a c. So similar to the vertex, you see the kind of correlation there between the x value and the x value of the reflection point. And then whatever the y-intercept is, that'll be the y value of that reflection point. We'll talk about kind of both the axis of symmetry and just using this order pair down below. Question so far? Peter?
Can you put the check mark thingies on a help sheet?
Check marks can go on a help sheet, as can the key points here. And the check marks, basically they're how can you be sure or be confident that you're doing these things correctly? Three things to look for. Number 1, don't cut corners. Okay, actually calculate the vertex, the y-intercept, and the reflection point. The faster we try and go through this, the less work that we show, the less organized we are, the more opportunities there are to make that mistake. So actually do it. Secondly, look at the sign of the A term. The A term tells you whether or not that parabola is going to open up or open down. And the nice part is there are no exceptions to that. If your A term is positive, your parabola is always going to be positive, going to be happy, smiley face. Okay? If the A term is negative, then you've got a frowny face, right? And there are no exceptions. And then number 3, which I don't think any of you use a graphing calculator regularly, But you can graph parabolas on these calculators. That's my son. He likes to come and say hi. You can graph them. I recommend that you do make the investment for these. They're like $110, but they'll take you through high school math, through calculus in college, as far as you need to go here, and you can graph equations on them. Okay? You can't use the internet like on a test or something. Not on a test or something, or a placement test. Okay? Ready to go? All right. Let's go down to the first one here. Our equation is y equals 2x squared plus 4x minus 3. And we're going to kind of look at the keys here to help make sure that we're working through this correctly. Which direction should this parabola open? Based on the equation, which direction should this parabola open? Thomas? Up. And how do you know? The a term, that 2 is positive, so we know the parabola opens up. If you get through this and you see that your parabola opens down, it's not that there's an exception to the rule. You need to go back and see what you missed. Okay. The vertex points. Remember, this is an ordered pair, and that x value comes from the formula negative b over 2a. So we look to our equation. Adam? Oh, look at you go. Yeah. We look to our equation here, and we see that the b value is 4. So our numerator is positive 4, but that negative sign makes it negative 4. And then our a value is 2. So we get negative 4 over 2 times 2, or negative 4 over 4, which does simplify to be negative 1. Okay? And again, all that gave us is the x value of the vertex. We're not done yet here. We take that negative 1, we go back to the original equation, and we plug it in for x. And if you're using a calculator for this, which I recommend that you do need to be very careful that when you put that negative number and you square it, you need parentheses around it, because there's a difference between squaring negative 1 in parentheses and squaring negative 1 without parentheses. Who knows what that difference is, how your calculator treats that differently. Even though in your mind you might think it's the same thing, how's your calculator treat it differently? James?
I think you're subtracting.
Well, kind of. It goes back to the order of operations. Peter?
It thinks since there's a negative sign in the 1 squared is 1, and would make it negative 1.
Right. According to the order of operations, the exponent needs to come first. Your calculator thinks all you want to square is the 1. And then it brings that negative sign over to get a final answer of negative 1. But in this case, because our x variable is negative and we're squaring that x value, we're squaring negative 1, which means we want that negative sign included. Thus, parentheses must be present, and negative 1 squared, negative 1 times negative 1 is a positive 1. Okay? So I kind of train myself to always put parentheses around this, whether it's positive or negative, just because if I do it every single time, then there's not a chance I'm going to miss it when I actually have to. So 2 times negative 1 squared plus 4 times negative 1 minus 3. Take out your calculator and type that in there just so we're all sure that we can do it. Put the parentheses in the right spot, and I'll get this correct answer here. If you type it in there correctly, what should you get?
1.
You don't get 1. Peter?
Negative 5.
You should get negative 5. So if you don't get negative 5, make sure that you've got parentheses where you should have them. Make sure that you've got negative numbers where you should have them. Is anybody having problems and not sure why and want me to come take a look? Yeah? Oh, so then you got to finish it out. So plus 4 times -1, then minus 3. Put the whole equation in there. -1, and then minus 3. Minus 3, yep. There you go. Okay, anybody else? Good? Okay, so now this represents our vertex point, and that's the mathy step. Everything else is just kind of looking at the equation. What's the y-intercept for this parabola? -3. So let's go ahead, before we get to the reflection point, let's go ahead and plot the 2 points we have. The y-intercept of -3 and the vertex of -1, -5. Oops, that's +1, -5. -1, -5. Okay? Now to find a reflection point, we kind of have 2 options we can go with here. We can either draw the axis of symmetry, which we'll start with that one. We know our vertex is that -1, -5 point, so drawing our axis of symmetry through that point, we said that the y-intercept is reflected over the axis of symmetry. So if the y-intercept is 1 unit away on the right side, our reflection point will be 1 unit away on the left side, right? That's what gives the parabola that symmetry. So that's where our point is going to be. That axis of symmetry is an imaginary line, but it's that folding point. It's that symmetry line. So now we can go ahead and connect these 3 points with a curve. And there's our parabola. Using the mathematical way for that reflection point, remember we said that it was -b over a and c. Well, -b over a essentially means we're doubling our vertex x value to be -2. And if we go back here, if we take out this 2 here, -4 divided by 2, -b over a gives us -2. And then our y-intercept point, our c, -3. -2, -3 is exactly where that point is. Right? Either way works. Drawing the axis of symmetry and reflecting, or kind of using this formula to get the actual point. Yeah, Peter.
It's kind of like a V shape.
It does. It's hard to make a good curve when they're narrow. When we get to graphing some wider ones, it's easier to do, but it's not so bad. Considering I failed art in 3rd grade, it looks pretty good. All right, let's go to the next one. Y equals -3x squared plus 12x minus 5. Which direction should this parabola open? Down. And we know that because that a value is negative. Our vertex points, the mathy step, xy ordered pair. That formula for the x value is -b over 2a. Go ahead and plug those numbers in and see if you can get that correct x value of our vertex point here. Remember the standard form here. Your a value is at -3, the coefficient of x squared. Your b value is that coefficient of x at 12. Don't forget about the negative sign in the formula. Okay? Which you should have a numerator of -12 and a denominator of 2 times -3. -b over 2a. Which simplifies to be -12 over -6, which simplifies to be 2. which is the x value of your vertex. Okay. Okay, so the x value of our vertex is 2. We got that from the formula. And now to get that y value, we take that 2, we plug it into the original equation, and we solve. So we have negative 3 times 2 squared. Notice I'm putting my 2 in parentheses, even though it's positive. Just get in the habit of it. Okay, so negative 3 times 2 squared plus 12 times 2, and then minus 5. This gives us negative 12 plus 24 minus 5. And you should get a final answer of, Joey, 7. Okay, 2, 7 is our vertex point. Anybody running into issues with the calculator, the input? Okay. What's the y-intercept? What's the y-intercept? Will? Negative 5. And this time, let's calculate the reflection point first and see if we're right. So the reflection point being negative b over a essentially eliminates that 2 from the vertex formula that we used there. So it's negative 12 divided by negative 3, which is positive 4. And what should our y value of the reflection point be? The y value is the same as the y-intercept, Blake. Negative 5. Right? Now, if you're getting confused with the negative b over a versus negative b over 2a, and there's too many, okay? Remember, there is another way you can find that reflection point. And so if that's better for you, then it doesn't matter. They both work out fine. So let's go ahead and plot our y-intercept, 0, negative 5. Let's plot our vertex, 2, 7. It's a narrow one again. Okay? And the biggest mistake that I see folks make is they'll go like this. Oh, okay, my reflection point is going to be right here, and here's my parabola. Right? And they look at it and say, oh, that opens up, but I'm supposed to open down. Oh, well, that's okay. This one must just be different. It's not different. Okay? What you did, if you got this, is you use your y-intercept as the vertex, right? Instead of our vertex as the vertex. Okay? So make sure that you are thinking, you are checking, you are it opens the right way that it should open. Our vertex point is 2, 7, which means that's where our axis of symmetry line goes through. And if you'd rather find the reflection point this method, that's perfectly fine. Okay, you'll notice our reflection point should be, based on what we wrote, 4, negative 5, which 4, negative 5 is right here. We can verify that's the correct spot because if you found it using the axis of symmetry, you'll notice that our y-intercept is 2 units to the left of the axis of symmetry. So our reflection point is going to be 2 units to the right of the axis of symmetry, right? Giving it that symmetrical look, which is the ordered pair 4, negative 5. Proof that using either this little formula or drawing the axis of symmetry and reflecting that y-intercept over it to make it symmetrical works. And now our parabola opens down. It's still a bit pointy, but that's okay. It's tough to do when it's that narrow, but there we have it. Okay. Questions on any of the steps that you're kind of getting stuck on here? We're done with the left and right, so Mackie, go ahead.
How do you get the x value of the y-intercept?
The x value of the y-intercept is always 0. That's why it's a y-intercept, right? So the x value is always 0. Anything else? Yeah.
So for the equation, -3 times 2 squared, the long one, which
Yep.
is plus 12.
Yep.
After 12, why did you put 2?
Because our x value that we got from the vertex is 2, and there are 2 x variables in the equation. So a 2 has to be plugged in for both of them. There's our x squared term. Here's our 12x term, but I replaced x with the 2. Okay? So you use this value twice when you plug it back in. You put it in for each x. Violet.
How'd you get the 4 in
The 4, so going from this negative b over a formula, our b is 12. So it would become negative 12 over a, which is negative 3. Negative 12 divided by negative 3 is positive 4. Or maybe you also noticed that the relationship between the x value of the vertex and the x value of the reflection point is just doubled. Right? 2 times 2 is 4. Negative 1 times 2 is negative 2. Okay? And again, if using this formula here for the reflection point is like, nope, sorry, it's not happening with me, you can draw that axis of symmetry through the vertex and reflect that y-intercept on the other side of it. It was 2 away here, so we go 2 away on the right side. It was 1 to the right here, so it's 1 to the left on the other side. 2 ways to find it. Thomas. The y for the y-intercept? That's just your value for c. Negative 5 there, negative 3 there. Okay? Morgan.
For the x part of the y-intercept, is it always 0?
Always. Yep. By definition, the x value of a y-intercept is 0. Always 0. Okay? Okay. There is going to be no homework for the weekend. New con. Hold up.
What am I doing?
Hold up. New con has been assigned. One of the assignments is graphing a parabola. So we'll cover this again on Monday if you want to wait until then to tackle that one. Or if you want to give it a shot over the weekend, if you feel like you understand this well. If you want to work ahead on PO54, be my guest. Right? Yes.
Yeah, I tried working ahead.
Yeah, there you run into some hiccups that we got to talk about. Folks, that's how you math.